Hello, welcome to the 8th week of this course. So, in the last 2 weeks, we studied about point estimation. Point estimation basically means that we were trying to get a point estimator, or you can say a single value for your population parameter. We were trying to estimate the population parameter there, and for that we came up with a single point estimate. And there we saw different methods, and we talked about unbiased estimation also and EM algorithm also. Now we are going to learn about hypothesis testing. We will first understand what is the concept of hypothesis testing, and then we will see how we can set up the hypothesis, and finally we will learn about different tests for mean, variance and proportions and approaches for making a statistical decision. So let us first understand what do we mean by these terms. What is hypothesis and what does it mean when you say hypothesis testing? Hypothesis basically is an assertion about the parameters of the population. So wherever you make a statement about the parameters of the population, note that it is not a statement about the sample statistic that you can make. That won't be a hypothesis. So for hypothesis, it is essential that it is some claim that has been made about the population parameter. For instance, suppose you want to compare the average monthly income of employees in 2 different departments. Then in that case, you can denote mu1 as the average monthly income in the first department, and likewise mu2 would be the average monthly income in the second department. Now, your interest may be to test whether the average monthly income of the first department is less than that of the second, or if it is greater than that. Are they equal or are they not equal? So various situations can be created in which you might be interested. So here in this case, if you see the last statement, here we have written mu1 less than mu2, right? Or mu1 greater than mu2. So here we are basically making a claim about the parameters of the population. It is not about the sample, because mu-i's, if you recall, mu-i's have been used for the population parameters, and we use the corresponding sample mean for x bar, right? So it is always a statement about the parameters of the population. Now, how do you check the claims? Suppose a manufacturer of LED light bulbs claims that their bulbs have an average lifespan of T hours, right? Somebody is making a claim about their LED light bulbs. Likewise, whenever you are conducting this coin tossing experiment, we often assume that the coin is unbiased or it is a fair coin. So how do you check whether the statements or these assertions are correct or not? For this, basically, we do hypothesis testing. So hypothesis testing primarily says that you have to test whether the claim or the hypothesis that has been made is correct or not. So for instance, if a manufacturer is making any claim about the lifespan of the LED light bulbs, then hypothesis, this is the claim that he has made. Now you want to test whether the claim that has been made is correct or not. So that basically comes under hypothesis testing. Okay, so here you start with the claim that has been made. Somebody is already making a claim about the parameter, and then you want to test it. Okay. So basically in this, we attempt to refute a specific claim about the population parameter based on the sample data. Okay. So for instance, if you're considering the manufacturer of LED light bulbs, so he has made a claim that the average lifespan of the LED light bulb is supposed to say 50,000 hours. Now, the quality control engineer there might be interested to see whether the which has been made is correct or not. In that case, what he will do is that he will then collect a sample from those LED light bulbs, whatever is the production lot. From there, he could select random sample of some LED bulbs, and he would study the lifespan of each of those. So for that, he will come up with certain value, and based upon that, he would finally conclude that the claim which was made is actually correct or not. Is it actually 50,000 hours, or if it is less than that? So whatever you do in this case in hypothesis testing is based upon the sample that you have collected. In estimation, what we did is, in point estimation, if you recall, there we were interested in a population parameter. There was no claim about the parameter, right? If the average lifespan of the bulb, so the same experiment, if you think in the estimation purpose, then in that scenario, what will happen? Suppose the quality control engineer might be interested to see what is the average lifespan of the bulbs produced in that company. So for that, what he will do, he will select a sample and then he will study certain properties, or you say the corresponding sample mean, and then he would come up with a single value that this is going to be the lifespan of the LED light bulbs manufactured in this facility. However, in hypothesis testing, what you are doing is, you are not starting with the sample first. First, somebody is making a claim about the population parameter. Somebody is claiming that, okay, this is the lifespan. Now you are going to check, your interest is into whether the claim that has been made is correct or not. And in order to verify that, then you will collect a sample, make certain formulations and check it, do some calculations, and then finally you would calculate, or you would come up with this solution that, or the conclusion that this is going to be the correct, this is the correct claim or not. Okay, so hypothesis testing and estimation differs in this way. Okay, so there is a little bit of way around how you deal with the sample. Both are based upon the sample only, but the way you start with these sample, or you start looking at the sample statistic, that is a bit different in both of these. Now, when we are talking about hypothesis testing, the first two common terms that rise are null hypothesis and alternative hypothesis. So null hypothesis, if you might have read somewhere, then null hypotheses are often denoted by this H suffix not. So not basically is to denote null. Okay, so whenever you want to frame a hypothesis as null or alternative, then you have to keep in mind that null hypothesis would always be the statement in which you doubt. Okay, or you can say that you will frame it in a way that it is a statement of no effect, or it is bringing no difference. On the other hand, alternative hypothesis basically is a condition that you believe in. Okay, so given any setup, you might believe in certain condition or you might not believe in that, right? So in whichever you have doubt, that you will write as the null hypothesis, and the other one in which you believe in, that will be written as the alternative hypothesis. Okay, so sometimes you might have seen that alternative hypotheses are referred to as the research hypothesis, and at places they just write alternative hypothesis. If you go to management research and all those studies, so they just write the alternative, and then based upon the sample they try to come up whether their sample supports this hypothesis or not. Now let us understand the examples so that you can fully understand the meaning of what is null and alternative. Suppose you are interested to see what is the relation between, suppose, say, education level and job performance. So you know that intuitively also and by experience that if you are educated, your education level is higher, then your job performance would also be better, right? You will be getting better job offers also. So if you have to make a null and alternative based upon the situation, then you basically believe in that higher education level improves the job performance. So in that case, you will write the alternative as the condition in which you believe. However, the condition in which you doubt is that education level has no influence on the job performance. So that you can frame as the null hypothesis. And why do we do that? That writing null as the condition in which we doubt, we will come to that in the next slide. Similarly, you can consider another example, that if you are interested to see whether the heart attack can be linked with drinking coffee or not. So in that case, we know that caffeine is not good for your health. So it would have certain impact on your functioning of heart also. So in this case, you can say that alternative is the one in which you believe. So you can say that drinking coffee increases the chances of heart attack. Rather, the null would be the one that you doubt. So you can say that heart attack has no link with drinking coffee. So it means that you doubt this condition, and that is why you have written it as the null hypothesis. Or maybe you can consider various other examples, like if you want to consider the height of children, right? So if you want to see if the parents have a good height, then children often tend to pick up that height. Otherwise, it is the other way around. So you might frame the hypothesis that tall fathers have tall children. So in that case, you can say that negation statement, the one in which you doubt, it will be tall fathers don't have tall children. Something like that you can frame as the null hypothesis. An alternative one will be that tall fathers tend to have tall children. So whenever you have any given situation, you have to first think of two criteria. You have to think whether the condition in which you believe in and in which you doubt. And the moment you are able to identify that, you can quickly write down the null and the alternative based upon that, as you can see in these two examples as well. Now, the question comes up is that how do we decide whether to reject the null hypothesis or not? How do you decide? Because we are saying that null hypothesis is the one in which we doubt. It means we would like to reject it, right? Because if I am having doubt in something, I would not like to prove that. I would like to reject that claim. So how do we do that? We do that by collecting a data, and if you find that if the sample data that you have collected is consistent with your null hypothesis, then you do not reject it. However, if the sample data is inconsistent with the null hypothesis but consistent with the alternative, you reject the null hypothesis and conclude that the alternative is true. So basically, you would be collecting a sample in order to test your hypothesis. You will collect a sample, you will do certain calculations, and then finally decide based upon the sample that whether the null hypothesis has to be rejected or not. Now, note that when we say rejecting the null hypothesis, it means that it is false. You can conclude that it is false. However, when you say you are accepting the null hypothesis, it does not mean that it is true. Okay, it is not true in general. It only says that you do not have enough evidence to believe otherwise. It is just the sample that is giving you the correct answer, right? It may not hold true in general. So based upon the sample that you have taken, it is giving you the result that, okay, null hypothesis is true. So that is why we always talk in terms of whether you reject a hypothesis or you fail to reject a hypothesis. Okay, it is a wrong practice to say that you accept the null hypothesis. Acceptance, instead of saying we accept, we say that we fail to reject it. Okay, so just keep these tricky things in mind so that you do not get confused later on. Now the next question is, why do we always try to reject the null hypothesis and why do not we just prove alternative? Right? If I am interested in certain statement and I want to check whether the claim that has been made, so why should I write the null hypothesis first, which is a negation statement, or you can say which is basically the condition in which I doubt, and then I try to write another one that is the alternative, which is the correct one in which I believe. So why should I try to reject the one in which I doubt? Why just I don't simply write a single hypothesis and say that, okay, I am going to prove this? That would be another approach, right? Because instead of writing two hypotheses and then rejecting the opposite one so that I can accept, or you can say I fail to reject that. So in that case, why don't we simply prove the alternative? The reason is that you cannot conclusively affirm a hypothesis, but you can conclusively negate it. It is difficult to prove something, rather it is easier to disprove something. Because if you can find a single observation or a single data set which rejects the null hypothesis, you can say that it is incorrect, right? You will reject the null hypothesis. Because whenever you are proving, suppose there is any concept and you have to find, sometimes you have to find examples in order to prove that. Sometimes you find a counter example in order to show that, okay, this is not going to happen. So you just find a single counter example. You do not go and keep on finding different counter examples again and again. Only a single counter example suffices to say that, okay, this statement is going to be wrong. So here also, if you have to reject the null hypothesis, if I can find out from the sample that I have, it is getting rejected, then my job is done. So I can easily accept the alternative one instead of proving it, because for proving it is not easy. So observations inconsistent with the hypothesis will disprove it, but if you find that this sample that you have, it is not proving it, if you are working with the alternative directly, and then you cannot say that, okay, this is going to be true in general also, right? So instead of that, we just try to frame your hypothesis into two parts. One is your null, the other one is alternative. Null is the one in which you doubt, alternative is the one in which you believe in. And finally, we try to reject the null hypothesis because we cannot conclusively prove that this is the alternative is true. So that is why we try to easily negate the null hypothesis and get done with our job. So this is the basic concept of hypothesis testing, and we often tend to get confused about these concepts. So I'm just explaining it to you beforehand. So now let us try to understand what are the two types of errors that we encounter in hypothesis testing, and why do we come across these two? Why do we even have these errors? So let us look at this table. This is a very common and famous table that you can get anywhere in all, I think in most of the textbooks it is there. So basically, when you are making any decision, you have two options. Decisions can be either you reject the null hypothesis or you fail to reject the null hypothesis. Likewise, the reality can be the null hypothesis can be true and null hypothesis can also be false. Now, error will happen whenever, if you look at this particular column, this particular cell over here, H0 is true and you reject it. So basically something is true and you are rejecting it. It means that you are committing type 1 error, right? This will be an error. However, if you come to this second one, here it is false and you are rejecting it. So that is fine to us because you are not making any mistake there. It is not an error. So we say that it is correct. Likewise, if you come to the third option, so H0 is true and you fail to reject it. It is correct and you are not rejecting it basically. So still it is fine. Yeah. And finally, when you come to this one, so type 2 error, here you are again making a mistake because something is false. Here you can see it is false and you fail to reject it. Something is incorrect and you are failing to reject it. It means that you are again committing an error, and that is referred to as your type 2 error. Okay. So in hypothesis testing, we always talk about these two types of errors, and these we are actually intuitively also you see that we are bound to make such errors because we are making conclusions based upon the sample, and even if the single observation changes, the entire conclusion might vary. So for that we will obviously come across certain types of mistakes, or you can say the errors. They are commonly referred to as the type 1 and type 2 errors. So basically you can keep in mind that if you are rejecting the null hypothesis when it is true, you commit type 1 error, and the probability of committing this type 1 error is basically referred to as alpha. Okay. So alpha is the probability of committing type 1 error. Likewise, if you fail to reject the null hypothesis when it is false, you commit type 2 error. So the probability of committing type 2 error is referred to as beta. So alpha and beta, they are not type 1 and type 2 error. You cannot just say this is type 1 and type 2 error. It is basically the probability associated with that. It is the probability of committing type 1 error, which is alpha, and the probability of committing type 2 error is beta. Okay, so whenever something is correct and still you are rejecting it, it means that it is type 1 error. and otherwise you say that you fail to reject it when it is false, it is referred to as your type 2 error. Okay. Also, you can think about it from manufacturing point of view, because there you will come across consumer's risk and producer's risk. So if the manufacturing lot that is there, it is good and the consumer rejects it, it means that it is good and you are rejecting it, then it is basically you are committing a type 1 error, and that will be producer's loss, right? Because something was of good quality and still the consumers have not accepted it. So it will be the loss at his end, because he has invested so much time and money and effort in that. Likewise, if it is of a poor quality and still the consumer accepts it, so in that case, it is not good, it is false, but you are still accepting it. You fail to reject that when it is false. So it is the consumer's risk. So these two are often referred to as producer's risk and consumer's risk in your quality control setup. So now let us look at this remark. Now alpha is referred to as the level of significance. So basically alpha is what? Probability of rejecting the null hypothesis when it is true. So another name for that is level of significance. The common values for alpha that we take is 0.05, 0.01 and 0.1. When I say alpha is 0.05, that is alpha is the level of significance, because alpha basically means that it is the probability of rejecting H0 given that H0 is true, right? So this is your alpha. And when I say that this alpha is 0.05, it means that I am willing to take 5% risk of rejecting the null hypothesis when it is true. Okay. Likewise, if alpha is 0.01, it would mean that I am willing to take 1% risk of rejecting the null hypothesis when it is true. So basically you are taking some sort of risk there when you are fixing some alpha value. Okay. So it depends upon the manufacturer or the one who is doing the study that how much risk is he willing to take. So it depends upon your problem or your setup, and based upon that you can decide whether you need to take alpha as 0.05 or 0.01 and so on. Okay, so it necessarily, whenever we are saying alpha is 0.05, so the first thing that should come to your mind is that okay, it is level of significance, and what does it actually mean? We are referring to it as basically the risk that you are willing to take when the null hypothesis is true and you are rejecting it. Okay, and if alpha is smaller, your beta, the probability of accepting a false null hypothesis would be larger, because there is some rejection region and there is some acceptance region. So basically when you are decreasing alpha, it means you are decreasing the probability of rejection. If rejection is decreasing, it means the probability of committing beta is increasing, right? Because then acceptance would increase. And in beta, what is the definition? Beta is the probability of failing to reject the null hypothesis when it is false. Okay, so that is why you see that these two types of errors, if you decrease one, the other would increase, and likewise would happen, right? Vice versa would happen. So what we do is that we try to fix one and then we try to minimize the other. And the general convention is to set up the hypothesis in such a way that type 1 error is more serious error. Okay, so whenever you have to frame your null and alternative, we just frame it in a way that type 1 is a more serious error. That is why we fix it. And when we say serious error, serious basically refers to when you are dealing with the loss of life. Okay, so that is the most serious condition, and that is why in statistical studies we consider type 1 error as the more serious one. Now let us consider some examples in order to understand this. Suppose a doctor has to choose between diagnosing a patient with a particular medical condition or stating that the patient does not have that condition. Okay, so either he will say that he has the particular condition, medical condition, or he would say that he does not have that. or he would say that he does not have it. So basically he has two hypotheses. That null hypothesis would be that the patient does not have the medical condition, versus the alternative one would be that the patient has that medical condition. Okay. Now type 1 error will be what? Type 1 error is committed if you are saying reject H0 when H0 is true. Basically it means H0 is true. It means that the patient does not have the medical condition, but the doctor is rejecting that claim and instead saying that patient has the medical condition, right? So same thing is written over here. Basically that type 1 error is committed if the doctor incorrectly diagnoses the patient with the medical condition. He diagnoses that patient has medical condition when in fact he does not have the condition, right? So this is a more serious one. And type 2 would be what? Fail to reject H0 when H0 is false. Something is false. This is false. Okay. Patient does not have the medical condition. This is basically false. It means the patient has the medical condition, right? Is suffering from that disease, but the doctor fails to reject that. Okay. So he says that patient does not have it. So you are not basically treating that patient. So here also you can say that if the doctor incorrectly diagnoses patient does not have the medical condition, when in reality the patient actually has the condition. So this is how you can frame your hypothesis. In a similar way, you can look at your second example. Suppose a manufacturer company produces electronic devices and an inspector is responsible for determining whether a specific device meets the quality standards or not. So the device, you can say the device is not of high quality. It means that the device is not meeting the quality standards. And the other one is the device is of high quality. It means that it meets the quality standard. Now your null would be reject H0 when it is true. So you are rejecting the null hypothesis when it is true. So the device is not of high quality, but you are rejecting that claim and you are saying that no, it is of good quality. Again, type 2 would be when you fail to reject the null hypothesis when it is false. So it means that it would be committed when the device is of high quality. Basically it meets the standards but is incorrectly labeled as not meeting the standards. So this is how you can construct different examples, and you can, from those examples, you can see that what is your type 1 and type 2 error. Now another thing is about your simple and composite hypothesis. So basically this is another like null and alternative hypothesis. This is another common term that we use, whether it is a simple or a composite hypothesis. So the hypothesis which basically specifies a probability model completely is referred to as your simple hypothesis. Otherwise it is referred to as the composite one. For instance, if X follows normal distribution with mean mu and variance sigma square, where both are unknown. Now if you frame your null hypothesis as this, that mu is 0 and sigma square is 1. So what is happening in this case? That you have said that it is coming from normal 0, 1, right? So now it is known that the distribution is normal, mean is 0 and variance is 1. So everything is specified about the distribution over here. You know the probability model completely. However, if you consider this, the other one, that mu is equal to mu naught. Now this mu naught can be anything, right? Mu naught, because we know that mu is in R, so mu naught can be any value. So it is not specified. We do not know it actually. So in that case, we would say that this is a composite hypothesis. This is not a simple hypothesis because the probability distribution is not specified clearly. Okay. So here, even if your sigma square, suppose sigma square is given to you as 1, is given to you, but still if you are framing mu is equal to mu naught, so one parameter is not unknown to you. So it won't be known completely. So that is why we refer to it as your composite hypothesis. Now, another common term that we are going to use over here in hypothesis testing is the test statistic. So basically it is the sample statistic that we have used earlier also. So when you use it in hypothesis testing, the role of sample statistic here is that based upon that we will decide whether you have to reject the null hypothesis or you fail to reject it. So that is why we say that it is a test statistic. So that is the term that we use here. Like you have x bar minus mu sigma by root n, or you will have x bar minus mu s by root n. So all those things, these we have studied earlier also, right? So here the name would be the test statistic. Now rejection region would be what? So basically we would learn about two different approaches for hypothesis testing. So for different approaches we need to have two different terms. So first approach is basically rejection region approach. So one is the rejection region approach. So what is a rejection region? It is the set of values for the test statistic that leads to rejection of the null hypothesis. So basically it would be that region or that set of values in which you are going to reject the null hypothesis. However, the non-rejection, obviously the name itself suggests that it would be the set of those values where you fail to reject the null hypothesis. So these things would be clear to you as we move ahead in the study. So what do they actually mean by looking at different examples? So critical value is the value of the test statistic that separate the rejection and the non-rejection region. Suppose it is like this, and this is basically some value over here. If it is greater than this, then we reject it. So this particular point over here, this would be your critical value, right? So below this, so this is your rejection region, and here it would be your acceptance region. So that value basically which divides your acceptance and rejection region is referred to as the critical value. Now this is about the rejection region approach. The other approach that we use is the p-value approach. So let us understand what is p-value. So p-value is basically the smallest significance level that leads us to rejecting the null hypothesis. So if you recall from alpha that we have studied earlier, alpha is the probability of rejecting the null, right, when it is true. Or basically when I said that alpha is 0.05, it means that I can take 5% risk of rejecting the null hypothesis when it is true, right? Now in the same facility, somebody is taking 5% risk, the other one could say, no, I would take only 0.1% risk, right? So in that way it can keep on going. Someone else can say, no, I would take 0.1. So p-value, so these are different levels of significance, but p-value is that significance level, that's the smallest significance level that leads us to rejecting the null hypothesis. You cannot go beyond that, it is that particular value. Okay. This is a very general definition for p-value. The technical definition would come now. So if the p-value is small, the basic notion is that if the p-value is less than the alpha, so you will fix an alpha first of all in your study and you will find the p-value, and if the p-value comes out as less than, so this is p is basically the p, if p-value is less than equal to alpha, you reject the null hypothesis, otherwise you fail to reject it. And a smaller p-value will favor the alternative, right? Because if the p-value is smaller, you are rejecting the null hypothesis, it means you are accepting the alternative, right? So that is, in that way it is coming from that statement only. Now the technical definition and the proper definition for p-value is basically, it is the probability that we would observe a more extreme statistic than we did if the null hypothesis was true. This is the important definition. This is just for your understanding, and you usually come across this, but this is the correct definition for p-value, which says that it is the probability that you would observe a more extreme statistic than you did if the null hypothesis was true. So provided the null hypothesis is true, would you be observing a more extreme statistic or not? So p-value is basically that probability that whether you are going to observe a extreme statistic or not. So to understand this, let us consider an example over here. Suppose a medical researcher is conducting a clinical trial to evaluate the effectiveness of a new drug in reducing the blood pressure. The drug is expected to have a mean reduction of 20 mmHg and the standard deviation of 4. Now, if you frame the hypothesis as that mu is 20, that mean reduction is 20, or it might be more, right? Whether it is giving you more reduction. In that case, if you are testing this hypothesis, what will happen is you will take the sample mean, and if the sample mean comes out as approximately 20, then you would say that your null hypothesis is true and you fail to reject this. So you fail to reject this and you reject the alternative one. And if it is high, suppose it comes out as 29 or 30 or something, then you would say that this is significantly high and you reject the null hypothesis, right? You would say that the alternative is correct. Now suppose that you take a random sample of size 36 and you find that the sample mean is just 22. Now, can you say that 22 is significantly high or not? Can you conclude it? Because 22 is very close to 20, right? That much margin of error you can have. So for that, to check whether it is going to happen or not, basically can be done using the p-value. So p-value says that if the null hypothesis is true, what is the probability that x bar could be as high or higher than 22? So you have observed that x bar is 22. P-value would tell you the probability that, okay, if the null hypothesis is true, that is, it is actually 20, then what is the probability that you are going to get a mean greater than 22 or not? Right? Because if you understand the scenario that null hypothesis is 20, null hypothesis is given to you, it means for the population parameter is 20. Now you are taking a sample, then you are getting 22. P-value is saying that given that the null hypothesis is true, it means that there is a population whose mean is 20, then what is the probability that you could get a value 22 or more than that? So that probability is basically calculated by this p-value concept. So here if you see probability that x bar could be 22 or greater than that, you are going to observe test statistic will take 22 or an extreme statistic, provided that mu is 20, that is the null hypothesis is true. Okay, now you know that you can standardize that. So you subtract x bar minus mu, okay, divided by sigma by root n. So this one would be z here. So in this case it would be 22. Here you subtract in this side. So mu x bar 22 minus 20 over sigma. Sigma is 4 given to you and you are given 36. Right? So basically this becomes your z. And you solve this probability that z is greater than or equal to 2. This is same as 1 minus of that. And if you look at the table, this basically comes out as 0.00135. So this probability is basically the p-value. And this is very, very small. So under the null hypothesis, what you have observed is highly unlikely. Basically, it means that if the population parameter is 20, population mean is 20, then it is highly unlikely that you would get a sample mean of 22 or more than that. Okay. So in that case, it means you are going to reject the null hypothesis and you would conclude that it is in fact greater than 20. Because null hypothesis is what? Mu is 20. Not mu naught, but mu is 20. And the other one is that mu is greater than 20. So you under this condition, it is not going to happen. It means it would be this. So you can conclude that the medicine that they are trying to introduce over here is basically that drug is effective, right? Because it is it is lowering the BP by more than 20. So in general, whenever p-value is less than alpha, you reject the null hypothesis. So the general test procedure for hypothesis testing is that first of all you have to state the null and the alternative one. Then you will find the test statistic, that is the sample statistic. Next you would adopt either the rejection region approach or the p-value approach, and then based upon that you would check the assumptions and draw conclusions. So here in this case you would, if you adopt this rejection region approach, you will be dealing with the critical value and you would be comparing it with that. And in this value, p-value, again, you will be calculating the p-value. So p-value is a more reliable method, and we will see why p-value is a good one as we do the examples. So we'll consider an example and then we will see in both the ways what is the answer, right, and why p-value is better. And finally, you will check the assumptions and draw conclusions. So rather, I would say that assumptions would be checked first of all here only. So you will draw conclusions in the end. So we have studied till now what is a hypothesis, what do you mean by null and alternative hypothesis, and the basic concept behind hypothesis testing. Why do we need it? Why are we rejecting the null? Why are we not proving it, right? What do we mean by when you are rejecting the null hypothesis? Then we came to the two different types of errors that we come across in hypothesis testing. What are those? What is meant by them? What is the technical meaning behind them? And we saw different examples for that. Then we came across some important terms again, which included your simple and the composite hypothesis. Then we came across your test statistic, rejection and non-rejection region, critical value, p-value, and we have seen the general test procedure here. So after this, we are going to learn about in different setups, like when you are going to test for mean or variance or proportion. So how do you do the hypothesis testing in those scenarios? Okay, thank you.